we are saying about the Avl tree concepts. Avl tree in data structure concepts. Avl tree, which is one of the binary tree and also satisfying with the binary search tree. So it will be mainly used for an height of the tree. It will be attained in both the subtrees of the each node have also to be roughly which equivalent height. Avl tree is an binary tree where the height of the tree differ from most probably one. The height of the node will be calculated is a -1, 0, and then +1. It will be performed balanced based on the balanced factor. So while we are checking this, the first one is which is not an AVL tree. Because of that, it is not the height will be balanced. Because of that, while we are calculating the balancing factor, for an 1 is in 0, 4 is in 0. And then for 3, we will be having a 1 minus 1 0. And then for 5, we will be having a we will be having with the 2. So it is not a balance. Sorry, it is not an AVN tree. But when we are in checking with the AVN tree, so it will be calculated with that uh, balancing factor 1, 4, and 10, which is in 0, 3, and 5. When we are calculating that 3 is in 0 for 5, we will be having -1. For 3, we will be having with the 1. So this is an AVL tree. But all the AVL trees will be performed based on the balancing factors. Balancing factor will be calculated as the uh, height of the left subtree minus height of the right subtree. Both will be calculated based on the our values. Suppose if the AVL tree of the height contains the at most 100 plus nodes for more than nodes for S of H. So while we are calculating with that, left side of the node, number of node in left subtree and number of nodes in a right subtree. We have a large number of node. There is an large imbalance between the subtrees. So it will be happen. Suppose you will be having a 500 plus trees, so you will not be able to have the balancing trees. So you have to calculating with the trees. Okay, so it will be calculated based on that height of the left subtree and also height of the right subtree plus one. So it is an operations of then AVL tree. While we are searching with the time complexity, so it will be an big O log n. While we are a minimum complexity, which is an also be an O log n. Insertion and deletion operations. Next, we are saying that while we are inserting values in the AVL tree, it should be an balancing, and also we have to follow the four rules. One is an left rotation, and then right rotation, and then left right rotation, and then next thing is a right left rotation. If it is an a right imbalanced, we have to do the left rotation. If it is an left imbalance, we have to do the right rotation. So this is an our rules for inserting our node, inserting the left subtree of the left child of the true, and then right side, and then right child. Well, we are inserting, this is in sample format before the rotation. So after the rotation, so we will be having single rotation or a double rotation is a maximum possible for rotating our axis. Next thing is an so sample AVL tree. Initially, we will be having with that 5, 3, 8, and 1 and 4. So additionally, we will be having inserting with the next values. Okay, 0.8, which means that less than 1. So it will consider with the left side. While we are calculating this, it will be having a imbalancing because of that left side values are additionally imbalancingly increased. So we have to do the rotation. So we have to do the rotation means x values and y value. So we have to rotate it, and then we have to get the final values after the rotations. So sometimes we are needed about the double side rotation. So with that, suppose AVL tree are imbalanced due to some subtrees. So we have to do some alterations in the root also. So here we will be having U, V, D, W, A, B, C. So it is a purely imbalancing. So first of all, we have to do the A and B, and then C and D, we have to rotate it. While we are doing in practical rotation, we have to insert the value 3.5. Initially, it is in a B position, so it is purely imbalancing. First of all, we have to do the imbalance value, and then we have to rotate the values. Then only we have to calculating the process. First of all, we have to do this in a left side. We have to do the right rotation, and then one left rotation. We have to do the process. So extended example. So suppose I want to insert the values 3.2, 1.4, 5, 6, 7, 16, 15, and 4. First step, we will insert the 3, that is a root, and the next value 2. That next value will be an 3, 2, 1. It is an also imbalancing. So we have to do the based on the balancing factor, we have to do the process. And then next thing in figure 5, we have to inserting the next value, and then we have to next insert it in a 1, 2, 3, 4, and 5 finally. Here next we have to insert the next value 6. So 6 we have to insert it is imbalancing. Again we have to do the rotation, then we have to insert the thing with the 6, and then next inserting our value of 7. Again it is an imbalancing, we have to do the rotation of our process. Again we have to insert the value 16, 16, and also it is in balancing, so no need of any corrections. Next we will do the value of 15, 15 also imbalanced, so we have to do the rotation. Next value, we will inserting the value of 14, 14 also imbalancing, so we have to do the rotations. Next thing we will see about the deletion of the rotation. So deletion also height will become with the big O log n. Okay, it is also do the same process in our deletion also. That's all about the AVL tree concepts. Thank you.